All right, so I want to do a quick overview recap on how to determine if your z-score is statistically significant. Because in reading through the discussion boards, there seems to be a little bit of misunderstanding about that. What we're doing with statistical significance, this concept was introduced in chapter 4, but keep in mind the premise of what we're trying to do here is to determine, is our result extreme enough that it was most likely not arrived at just by pure coincidence, just by chance. So when I say I have reached a p-value of less than 0.05, I'm saying I'm confident that the result that I got that there's less than a 5% chance that this was just a coincidence, that this happened just as an off chance, right? If I were to do a special study skills seminar for chemistry, and I said, oh, hey, the 10 students who did this got a half a point higher on average on their chemistry final, it would be easy to look at that and say, okay, but out of the hundreds of students who go through intro to chemistry every year here, couldn't you have by coincidence picked 10 people that ended up with half a point higher? That's not really that impressive, right? So a z-score gives us a way to consider our mean, our standard deviation, and determine this group that we're looking at, what is the likelihood that this was just purely by coincidence? So, and I'm sorry you see dogs and little legs and hear noise. I am trying to do this on summer break while everyone is home. So I'm working with what I got here. All right, so this is our normal distribution table. This 0 right here represents a z-score of 0. And I've just plotted out for 0, 1, and 2, and 0, -1, and -2. And I've copied down the markers that your textbook has told you. So for a 5% significance level on a two-tailed test, you need to get above a 1.96 on the positive side or below a -1.96 on the negative side. For a significance level of 1%, you need to get above a 2.58 on the positive side or below a -2.58 on the negative side. Standard for behavioral sciences research is this 5% marker. So what you're doing is when you do your math and when you get your z-score, you're going to take it, and it would be helpful to just draw this out. Just get some scratch paper and draw this out. So you can take your z-score and you can mark it. So if you get a z-score of 0.7 and you're over here, you do not fall in the range of statistical significance. If you get a z-score of -2.2 and you're over here, you can see, okay, so that number, this -2.2 I just got, falls within this area of -1.96 or more extreme. Your textbook shows it shaded, right? My plot fell within the shaded area, so I know that it's significant. If for some reason I was wanting to set a 1% level, I'd have this over here shaded. If I got let's say I got a 2.1, that's over here. That did not fall within the shaded area. I can't accept my research hypothesis. I failed to reject my null hypothesis. But if I get a result of 2.7 over here, I'm in this shaded area. So I know I can accept my research hypothesis and reject my null hypothesis. So when I ask on the discussion board or on the assignment, how do you know if you can reject your null or if you have to reject your research hypothesis? This is what I'm talking about, is this method where you're comparing your z-score result to what would be a statistically significant z-score result. So hopefully that helps clear some things up. Please let me know if there's still some additional questions. Just for reference, this concept was first introduced on page 112 and 113 in your textbook back in chapter 4. And it's steps 3 and 5 in the hypothesis testing process. So looking at your cutoff score critical value and then comparing your own z-score to your cutoff value. So let me know if there's still questions after this.